Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to the 50th episode of Hardware to Save a Planet. I can't believe it's been almost 2 years now since I first sat down to record, having no idea where this show would go or how long it would last. And the experience has blown away my expectations in so many ways. I've learned so much, met some really amazing people. The climate tech community has expanded like crazy, and the audience for this show is way bigger than I ever expected. So thank you to everyone out there who's listening and supporting the show. What I wanted to do for this milestone episode is call back a few of our earliest guests to see how things have changed about their business, the industries around them, and their hardware. We'll talk with Erika Boeing of Accelerate Wind from episode 1, Peter Reinhardt of Charm Industrial from episode 2, and McQueen of Heirloom from episode 4. I'll do a really quick intro to each, but I'd recommend going back and revisiting their original episodes. Let's get into it. So I was excited to talk with Erika because when we first chatted, she told me that they were actively testing their first physical prototype at Argonne National Labs. I wanted to see how that testing went and how both the physical hardware and her business has progressed. As a quick refresher, Erika's core innovation is a spoiler design that sits at the edge of flat top roofs and directs the fast-moving wind at the corner of those roofs down toward the surface of the roof where it can be captured by wind turbines. Her solution works in conjunction with rooftop solar, not in competition with it, giving businesses a way to augment solar to supply more renewable energy.
Good to see you.
You too. Great to see you. How are you?
I'm good.
I guess last time I saw you was at IGF.
Yeah. Are you going again this year?
I'll be there, yeah.
Nice.
You?
I'm undecided. I had such a blast last year though, seeing and literally everyone. It was just like a giant freaking reunion.
Yeah, it's an awesome event. If I remember right, when we talked, so cast our minds back, this was sometime in 2021. I'd love to hear how things have progressed with the company, with your hardware specifically, and then also just thinking about how the context around the company has changed, how the industry is changing, how the funding environment or anything that is relevant to your business outside of the business itself. But what was standing out in my mind is you were telling me when we last talked that you had a prototype being tested at Argonne National Labs, I believe. You were starting the process of doing real world testing of your designs.
Yeah, a lot has happened since then. We finished up our testing at Argonne. That was version 1 of the tech. It went super well. We were able to prove out our core IP. So as a refresher on that, one of the core pieces of our technology is we capture wind as it goes over the edge of the roof. And then we have the spoiler that we've patented that will actually let us draw that wind down so we can capture it close to the roof. Typically, you would need a tall tower to capture the wind as it accelerates over a building. And so that spoiler lets us not do that. We tested at Argonne our spoiler with an off-the-shelf turbine to really prove that we were able to capture that edge of roof effect. It worked really well. It matched our model super well. And then it even withstood 150 mile per hour wind event.
Wow.
I don't think it was quite that much on the ground, but that's what we measured up on top of the spoiler. And it was like this crazy windstorm where everybody had to lock down inside of Argonne. And we're glad to leave the building. And so we were like, oh crap, what's going to happen to our system? But it was fine, which is really good validation for performance in extreme weather. That went well. That's wrapped up now. And then we've been testing an evolved version of our system at this third-party test site, Windward Engineering in Utah. They've been testing wind turbines for the last 25 years or so. We've built up a mock building there out of shipping containers and then installed our spoiler. And we're about to install now a turbine that we've actually designed in partnership with another group and do really thorough testing on that to make sure that it's way over designed and super safe for pilot installs. So do a really thorough loads validation. Because it's on shipping containers simulating a building, we can do fun things like pick up the shipping containers and turn them to test wind coming from a different angle, because it almost always comes from the same angle at that site. Yeah. And then we're testing a few things that you can't test in simulation, blade lengths and a couple parameters that we think we might want to change, and using that to validate our models to make sure that we have the right configuration going into pilots. So far, so good. We've done a lot of validation on the spoiler and it all looks like very close to our models. We've done some cool tests that I could talk about. It's interesting from a hardware perspective to be able to image the wind as it goes over the system using fake snow and GoPro, so that we can actually, like what you normally do in a wind tunnel, but in the real world, track each particle as it goes over the system, and then use image processing to back out what is actually happening with the flow. So we can compare pixel by pixel to our simulations and make sure it's doing what we expect it to do.
And why aren't you in a wind tunnel? What's the value of doing it in this less controlled environment?
We were going to go to a wind tunnel, but actually, when we priced it out, usually the reason you do it in a wind tunnel is you can build a scaled down model and it's cheaper and you can get just some quick experiments before you build the whole thing. When we priced it out, in order to really simulate the rotor behavior, we would have to spin a smaller rotor so fast that it would require like exotic materials and just as expensive as building the full scale version. And so then since we had this site where it was like a pseudo wind tunnel where the wind is really predictable, we figured why not get it in a way that it's more accurate. Reynolds number matters a lot too. And that's part of the reason we have to spin it really fast and then use really high wind speeds. But Reynolds number matters. And so we could just get it with the right conditions that's more comparable to the real world for the same price. That seemed like the way to go.
So it sounds like things are matching simulations. How much uncertainty did you have going into those tests that things would match the simulation?
We'd done a lot of simulation and simulated it from a lot of different angles because I wanted to be really thorough about it. And the results were all pretty similar. So that made me feel good. But with CFD, you just don't know. Like you hear all kinds of stories of people running things in CFD and then going to the real world and it doesn't perform the same at all. There's still some fluids uncertainty. And so until we saw it, I didn't know for sure. That was good to get that actual validation. And we still have some to go. So we'll learn a lot from testing our turbine as well. We have a pretty good feeling for how it's going to work. But once we get some test data, we're actually creating a whole new simulation to validate that so that we can use that to extrapolate more.
Tell me if this is right. You started in simulation and then you had these tests at Argonne where you're confirming essentially that sort of proof of principle, like you are able to capture the wind and divert it lower down towards the roof where your turbines are located. At some point, I imagine the engineering focus evolves to being more focused on design for reliability and these high wind scenarios and safety and things like that. And then at some point, you have grand commercial ambitions. You need to design for high volume manufacturing and cost optimization and optimize your supply chain and all of that. Is that a fair characterization of sort of the path? And I'm curious where you are on that.
I think it's a pretty fair characterization. And yeah, I think for the most part, we're somewhere between the reliability and the design for manufacture side at this point in time. There's some optimization work to be done. Like when we test the turbine, there will always be optimization work to be done. There's something that I know we want to look at once we test the turbine, because this will be our first test with the turbine that we're actually building. But for the most part, we're really focused on reliability, design for manufacture. Reliability, largely, we have a couple of pilots that we're pursuing right now. So we're getting ready to move into that like pilot phase in a big way. The first one, we've been working with the General Services Administration under this Green Proving Ground program, where they will test clean tech on their buildings and pay for the installation of that. And then it makes it a lot easier to install on other federal buildings once you've gone through that testing with them. And so we're busy planning that. We're working with a couple other corporate customers to look at pilot sites. And so before we do any of that, like the reliability is super critical. We want to make sure that we have something that is going to work well. And then we'll learn from those pilots and then really move into the scale-up phase. And so we're planning for those design for manufacture scale-up phases, making sure that things can be manufactured at volume at the cost that we need them to be, but not actually like pulling the trigger on every single piece of that yet. We're just feasibility check on all the manufacturing sides.
What are the biggest risks from a reliability and safety standpoint? Are we just talking, is it just about super high wind speeds?
Worst case is the super high wind speeds. So a lot of buildings, like their code, will make you design for up to 120 mile an hour per winds. That's by far the worst scenario from like a loads standpoint. But then there's a bunch of other things that like the standards rightfully make you go into and measure. So like both around like fatigue, and fatigue is a big one.
And if I remember right, your sort of core IP is the spoiler that you mentioned. To what extent do you have to innovate on the turbine itself or the design of the turbine. I think you had a partner for that you mentioned.
Yeah, we have a group that we're working with on that. They've been developing this type of turbine for a long time. And then we're working together on what do we need to do to evolve that design to fit into our spoiler. So there are some things like because the presence of the building and the spoiler does change the aerodynamics. It's still the same, similar functional design, but you may change some of the geometry of the blades or the pitch angle of the blades in order to fit into our exact configuration and produce power the most reliably and the most power. It's like we're putting a turbine inside of a wind tunnel where you get a bunch of blockage from the walls, but we intentionally are using that blockage to speed up the flow, and that your most optimal turbine is going to be different for that.
So I'm curious about the commercial side too. So you have these pilots going. How has that come to be? Has that been a big part of your day-to-day, and what does that look like?
It's been a big focus. So we've been getting a lot more interest from bigger commercial customers that in the past, we always thought our transition plan was going to be like, okay, we'll start with the smaller, like early adopters, and then some of the bigger, like Fortune 500 companies are more risk averse. And so we'll want to prove it out other places, and then we'll scale up in like size of building. But because of I think the IRA giving incentives, a lot more pressure for companies to set aggressive climate goals. There's just been this huge shift over the past couple of years. And people that we talked to 3 or 4 years ago who were like, yeah, I don't know, we're conservative, but it's cool. Talk to us when you have 100 units out there, are now spinning up their own initiatives and actively looking into things like distributed wind. So that's been huge for us.
This would be a big corporation that has a net zero target is saying one way we're going to decarbonize our what scope 2 emissions would be to put augment solar on our roofs with wind on our roofs.
Solar won't get us all the way there. We're doing solar where we can, but we need more. And so what else can we do? And then they turn to look for wind solutions.
That is a good segue. I was going to ask, I remember one thing that really stood out to me about your strategy was, and I don't know if you would say it this way, but you're almost like standing on the shoulders of the solar industry. Like they have this amazing...
Yeah, I think we said that. Yeah.
almost, if I understood it, like selling through solar companies and making sure your systems could be installed by the same people installing solar panels, and you're not competing for the same real estate on the roof and all of this.
Yep.
Is that still core to the strategy?
Yeah, that's absolutely still the plan. We're still working with solar installers regularly on that. For our pilots, we're the ones who are doing the installation and the design work so we can learn from that, refine the technology, but then we're designing it all very explicitly so that it can be installed by solar installers. And that's a really important go-to-market because they're already really good, at things like customer acquisition, installation, permitting, financing, things that are like super regional that we wouldn't necessarily want to spin up like an accelerate wind department in every single city to get that off the ground.
So is that almost a parallel commercial effort happening right now to try to build relationships with solar installers? Are you already on that path?
It is. We did a lot of that early on. It's actually funny. Earlier on, because of the market shift, like solar installers were like, we spent a lot more time building relationships with them because they were trying to sell to their customers too. Now the commercial customers are way more interested. So I'd say it's more of a split, like 50-50 between talking to commercial customers and solar installers. But we're still, it is good. Good to have more inbound marketing.
Yeah.
But still, all of our pilots, we are actively working with solar installers. And for each test that we do, we're having people like come in and view the installation process and give us feedback and let us know what's easy and hard, and so that we can like actively iterate and make sure it's something that would be able to be installed by solar installers in almost every location. So on the design side, we're super focused. On the partnership side, that'll probably come a little bit that'll probably become more of a focus after we get through like the first pilot or so.
What has been harder than you expected?
That's a good question. I knew it was going to take a while. This is an obvious answer. I feel like probably everybody must give you this answer, but hardware development time. Especially like some with COVID that made things more logistically difficult, but things just always take a little bit longer than you expect. And especially like to really get to that reliability, super reliable turbine. So we've been at it for a while. We think we're super close right now. So that we've also been growing a lot. For the first several years, it was like me and a couple others in a lab. And so growing more into like an organization that instead of it being me holding a bunch of design details in my head, distributing that more and really getting a well-functioning team. I'm sure that's going to be a step function every time that we go to each each piece. But we've been going through that over the past year or so. And I think I under anticipated that. It's been good. I think we're in a good place now, but it's been a lot of work to transition all that knowledge and everything.
It's exciting though.
Yeah.
When we last talked, you said you had a pretty decent amount of practical optimism about the future of the planet. You were saying, I just went back and listened to our last episode. You were saying that optimism was partly, at least, from how much climate change has entered the conversation generally over the last several years, part of politics and just general zeitgeist and everything. I'm curious if your perspective on that has changed. Where's your level of optimism these days?
Yeah, that does sound like something that I was riffing on a lot in like 2021. I think that's still true with all the stuff that I've talked about, like with the IRA, just a lot more movement from corporations. Like when all of that came out, that was honestly the first time that I was just like, okay, we really have a shot at doing all this. I guess I was optimistic in 2021, but maybe it was a choice. And I think it was true. The political discourse was trending in that direction. But seeing all those things come out, I think that's only heightened. Of course, it's also all becoming more real as we're seeing impacts of climate change. And so there's concerns there and more time pressure there. So I perhaps think about that a little bit more these days. But yeah, I think practical optimism. I think I'm still making that choice to be practically optimistic. That's the way that we get things done. And I do think that there's been a lot more focus on. I'm also really optimistic. I really love where policy and discourse has gone around not only like setting aggressive goals and really putting money behind reaching those goals, but all the initiatives around like environmental justice. I think that's super cool. That's just been embedded everywhere. Like we're seeing it in all the proposals and things that we write and like making sure that lower income communities really benefit from these technologies. Because I'm an engineer, I say I'm cautiously optimistic about that too. I guess I'm cautiously optimistic about everything as an engineer.
Help me tie that to the work you're doing. Like in what way does the social justice aspect of it come into play when you're writing proposals?
The proposals, though, almost all of the like demonstration projects that we've been applying for, they now have like a DEIA section that we have to write about how we're considering that either within our team or from like a workforce development and job training as we go forward and commercialize, or are we installing in lower income areas that will benefit? And it's really embedded that they're at least in the grants world, people are forced to think about it ahead of time. And then in policy, there's a lot of extra incentives too. In the IRA, there's adders to your tax incentives for installing in lower income areas or like the energy justice communities. And so there's money behind it too that are pushing people in that direction. Yeah, those are the things that we see the most of right now. The other thing that I'm seeing is because of the momentum in the public and private spheres, I'm seeing a lot of investors also who weren't interested in climate change before jump on and be like, yeah, I guess our problems really aren't going away. These are good things to invest in. And so that's also helped with the optimism too.
Awesome. Erika, it's really fun to see all the progress you're making. Congrats on all of that. Thanks for the updates.
Yeah, it's great to catch up.
Next, I'll give Peter Reinhardt a call. After selling his last company segment to Twilio for $3 billion, he founded Charm Industrial to provide the high-quality, durable carbon removals that he couldn't find on the market at the time. Charm's solution is to convert biomass into bio-oil and inject it underground with mobile pyrolyzers. When we first talked, we mostly talked about carbon removal, but he also mentioned his bio-oil could be used for carbon-negative steel production. So I've been wanting to hear how that side of the business is progressing. All right. Peter, welcome back to Hardware to Save a Planet.
Thanks for having me.
When we talked last, and I remember that conversation really well because it really helped me understand the world of carbon removal in a much deeper way. So as I understand it, regardless of whether you're building or whether you're using your bio-oil for carbon removal or steel production, you have these mobile pyrolyzers you need to develop and get out into the world to take all this biomass and turn it into bio-oil. And I think you were in the early prototyping stages of developing those when we talked last. So I'd love to start with just how is that progressing? How's the hardware looking these days?
Yeah, maybe the first thing to explain is we split out part of the problem, which we have both production of bio-oil as a challenge and also injecting the bio-oil into deep underground for carbon removal as a challenge. And then the third part here, which is using the bio-oil for iron making, is like these are independent hardware programs. We initially were more focused actually on buying third-party bio-oil. And then solving more of the injection side of understanding what happens in the subsurface, which types of formations are actually good. How do you do some of the chemical preparation to ensure that the biooil is, if it's going into a salt cavern, for example, that it's not going to dissolve the walls of the salt cavern. So how do you make the biooil saline? Things like that, which sounds easy, but it's a little harder in practice because you get things like phase separation and other nasty bits. We've done a lot of chemistry development, a lot of lab testing and geology research. We've injected it in a handful of different formations and learned a lot about permitting in different jurisdictions. So that's the injection side, and we're in the process now of ramping up injections into salt caverns.
You focused on buying bio-oil just so that you could continue development of the injection process. Your goal is always to generate your own bio-oil, but to ramp up the injection process, you needed to have a source of bio-oil.
Yeah, exactly. You get to parallelize the learnings. I think one of the hardest things in hardware as compared to my prior software life is things have real timelines. Like you just can't do everything overnight. The bottleneck oftentimes is actually moving around pieces of hardware in one form or another with supply chain or assembly or these things. Whereas in the software world, it's like you're usually bottlenecked more in your understanding of the customer problem in terms of how you're designing the interface or whatever. So yeah, parallelism in our efforts is like a big enabler of moving fast. And so here, like being able to parallelize learnings on the injection side, really important actually for an understanding what should the spec of the bio-oil look like. That has changed a good bit of like what matters in terms of pH and salinity and other kind of like viscosity and other properties of the bio-oil that really matter. So parallelizing those learnings has been really important. On the pyrolysis side, we've gone from like very early prototypes to now have been iterating, really proud of the engineering team and in particular like Grace's leadership over the last year, leading the engineering team through a really rapid iteration cycle on our pyrolysis systems. So these are at a smaller scale than we plan to deploy eventually. These are like 2 ton per day biomass systems, but she and the team have been able to iterate like once every 4 months or so on like a new design rev through contract manufacturing and commissioning and so on. What's cool about these machines, you don't launch them to space. They're not like, we look at like a SpaceX development kind of schedule or whatever. And like when you press launch, it like blows up on the pad or goes to orbit and it's gone. But that's not the case with a pyrolyzer. Pyrolyzer, you can like iterate on in the backyard and learn from very quickly. Yeah, making good progress there and excited about the ramp on our own pyrolysis operations this year.
How are you piloting? Are you working with like kind of beta customers early on? Are you importing biomass into your facilities and doing testing there?
We operate all this on the pyrolysis side out of our facility in Fort Lupton, Colorado. And the primary feedstock there, we looked at corn stover, but in that particular area, the counterfactual emissions for corn stover weren't ideal. And so we're actually using wildfire fuel load reduction and wildfire prevention materials. Yeah, there's a lot of that activity in the Colorado mountains, and it's like massive oversupply of material. And a lot of it is waiting for pile burns and the right season and right opportunity and staffing and so on. So anyways, we can help mitigate a tinderbox, if you will, which has massive community benefits when you think about the particulate and NOx and SOx and other nasties they get, whether it's a pile burn or a wildfire, the kind of nasties that go into the air that then we all breathe. So yeah, we like particulate matter, for example, we reduced by 70x, I think.
Oh, wow.
Through our process. Yeah, great community benefits and helpful to preserving our forests. And it's a great feedstock for us.
Yeah. Is that scalable in the same way that the agricultural biomass is?
No, the agricultural biomass is probably 10x larger, at least in the United States, maybe higher elsewhere, but it's still a great place to start. And I guess in terms of operations, yeah, excited. We've been building the operations team in Fort Lupton, amazing crews, and cutting over to like 24/7. We did cut over to 24/7 operations, which is a big shift, but these machines want to be run all the time.
Okay.
Yeah, we're working through that ramp and biomass processing as well as pyrolysis. And then I guess you also asked on the customer side in terms of pilots. We about a year ago signed agreements with Frontier. There's a $53 million purchase from them of carbon removal from Charm, over 100,000 tons of carbon removal between now and 2030. And JP Morgan also purchased 25,000 tons of removal and much further. Those are the customers that some customers, we're starting to work towards fulfilling some of those contracts off the back of this supply chain that we're standing up.
Yeah, no, I've been watching some of that news. Those are incredible agreements. And I've come to understand that these kind of advanced purchases like that are really key to fueling your growth. I remember you had said you were characterizing the growth this industry needs to go on. And our goal is to get to 10 billion tons by 2050. to stay under 2 degrees, that means this industry needs to grow by a factor of 1.5 to 2 million in that time frame, which is like the 65% compound growth for 28 years when we were talking. And what stands out to me is you said it's like twice as fast as the software industry has grown. 2 years later, almost 2 years later, are we tracking to that growth trajectory as an industry?
The past couple of years have tracked well. I'd say there's been a lull in purchasing over the last 6 to 9 months, more broadly with like interest rates jumping around and that particularly negatively impacting tech and finance as two of the initial buyer categories. So I do think that it's now a little bit off track. And if the trend continues, it'll be like way off track by 2030. So I do think there's actually like a pretty acute need for carbon removal purchasing just to stay on track with it. We're talking about a few $100 million has gone into purchases of carbon removal at this point. And to be on that kind of rate for that we're talking about for 2050 or so, it needs to be like billions of dollars purchased in 2030. So it's like a lot. It's like way more than is happening. Yeah, and I think there are some structural challenges to that. Things like guidance for how removals should be accounted for in the greenhouse gas protocol, guidance from SBTi for corporates around. Currently, they basically guide to, in 2050, you can start using removals for like your final 10% or whatever, which is like aligned. But like that means there has to be a physical ramp. Like we can't just show up and like suddenly build all this infrastructure in 2050.
Right. You can't turn it on in 2050.
It's not going to fucking work. So in order for it to be really science-based, it needs to start a ramp. And at the growth rate that we've seen so far from in 2023 and 2023 to 2024, we're like way off pace. If that trend continues, if the buying doesn't pick up, then I actually think it could be very tough. Like you might gut the supply basically and force like a 10-year reset, like clean tech 1.0. So we'll see what happens. But yeah, there definitely needs to be more buying in the market.
Let's hit steel really quick. You said, because I just went back and looked at our last chat, 1.8 billion tons of steel are produced a year. That makes up about 8% of all emissions. And at the time, and when we talked in 21, only 100 tons had ever been made fossil-free. So in a lot of ways, this feels like a bigger opportunity, a bigger potential to make an impact on total emissions than CDR. I'm curious kind of what your strategy is there and how you're approaching that.
Yeah, using bio-oil for iron making works now. We've demonstrated that on 2 different iron making processes. And our metallurgy staff scientist, Brian Jameson, will be presenting that at an upcoming AIST, which I think is the American Institute of Steel and Technology, something like that. And yeah, excited about that. We've demonstrated it. The general principle is that in iron making, you're taking iron oxide and you're ripping the oxygens off in order to make metallic iron. And you rip those oxygens off using carbon monoxide and hydrogen. And you get carbon monoxide and hydrogen from either coal. If you burn coal at high temperatures, you get carbon monoxide. And then the carbon monoxide becomes the chemical reactant in the reduction process to make iron. Or you can get carbon monoxide and hydrogen from steam reforming natural gas. Those are the 2 processes today. Coal is about 93% of production, and natural gas is the other 7% globally. And we can make carbon monoxide and hydrogen from bio-oil. We just gasify it. At a high level, you can make the same reactants and drive the same process of direct reduction. And so that's what we've demonstrated, and we're dialing that in, and I'm excited to keep moving it forward from there. What's really cool about that process, in my mind, is that we not only can make fossil-free iron, but you, off the back of it, get a pure CO2 stream, which can still be sequestered. The potential there is there for actually carbon negative, like carbon removal combined with fossil-free iron making.
So turning this big emitting industry into actually a carbon removal industry. And so, yeah.
Yeah, exactly. Can you flip the +8 to -6?
Yeah, that's incredible. I'm curious if this is the right way to look at it, but at some point you'll have bio-oil and you can decide it could either be injected underground or it could be going to make a carbon negative steel. Will you have to be prioritizing one or the other, or can you do both?
The relative price of the two will ultimately set the decision. We have the flexibility in our company charter to optimize for impact, and the iron making impact is higher because you both have the reduction, and if you sequester off the back end, you also get the removal. But I suspect that in the long run, the markets will value the iron making plus the carbon removal higher and probably value the reduction higher because there's not going to be a lot of options for reduction. That 100 tons of fossil-free iron that you said that's ever been made, or that I told you had ever been made, that's still the case. It's still 100 tons.
Oh.
No one made any fossil-free iron last year. It's figuring out how to reduce the emissions in iron making is an unsolved problem, I would say. There's some exciting progress. H2 Green Steel is building a new plant in northern Sweden. SSAB Hybrid just announced they're going to build, I think, a plant here in the US with some DOE money, but they're not built yet.
It's really fun to catch up and hear everything you've been progressing. Maybe just last question. What are you excited about for Charm's future? What do we have to look forward to here?
Ramping up deliveries. That's what we're here to do. We're here to deliver carbon removal, trying to ramp those up as fast as we can. Yeah, excited to share more videos and photos and so on from the field of the real thing happening.
Awesome. Thanks a lot, Peter.
Yeah, thank you.
Next is Noah McQueen, a co-founder of Heirloom, which has a process for removing atmospheric CO2 by accelerating a natural mineralization process. I've seen some big updates from Heirloom in the news since we last talked, including opening the first commercial direct air capture facility in North America. So I'm super excited to hear about how things are going with them.
It's good to see you.
Yeah, it's good to see you too.
So last time we talked, so it was almost 2 years ago, I think you were doing carbon removals in your facility in the Bay Area. And I believe you said you were projecting to have a pilot facility, like an actual plant in the real world outside your facility in the next year or so. So I'd love to hear how that's going and what has happened since we chatted.
Yeah, a lot has happened since we last chatted. In addition to a lot of technical milestones, we've grown our team to over 100 people. Stored CO2 from direct air capture into concrete for the first time ever. As you alluded to, we opened our first commercial facility, and the first commercial direct air capture facility in North America will be producing carbon removal credits that equate to 1 ton of CO2 removed from the atmosphere. And the facility itself can capture up to 1,000 tons of carbon dioxide from the atmosphere every year. And this is super exciting for us because we are doing this the right way and trying to set a precedent for responsible direct air capture. So being with that context, working in partnership with local unions, paying prevailing wages, fully powered by renewables, fully decoupled from things like enhanced oil recovery, and directly responsive to both Governor Newsom's and Biden's net zero plans. Really excited to share this facility and the technology with the world.
Just to pick up on a couple of those things, fully renewable energy is important. If I remember your process, you're adsorbing the CO2 in a mineral and then using heat to desorb the CO2 so you can then take it in concentrated form and inject it underground. And I imagine that heating process is probably where a lot of that desorb is where a lot of the energy goes. You're able to do that fully with renewable electricity.
Our complete process is powered by renewable electricity, even the heating process. So we can use things like electrical resistance heating that provides the temperature needed to pull off our CO2 from these minerals, which is really important for direct air capture because to net remove CO2 from the atmosphere, so to remove more CO2 than you emit, you have to use renewable electrons and you have to be sustainable in the way that you both build and operate these facilities.
My understanding is we have fluctuating levels of renewable energy available on the grid at any given time, just given the fluctuating levels of solar energy and wind. Do you use energy storage to level that out, or how do you ensure you're always able to operate with renewables?
Yeah, so right now we're working in a VPPA PPA structure. So we're purchasing power from, specifically at this facility, it's Ava Community Energy, through additional renewable assets that have been built or are being built specifically to supply our first commercial facility and other projects like it. In this kind of framework, Heirloom is purchasing renewable energy at a premium, and that allows or contributes to this kind of pool of capital that's dedicated to building new or net new renewable energy. And those assets are producing energy or coming online close to or in conjunction with how we're ramping the facility. Going forward, we'll work with energy partners to ensure an agreement that we can match the exact energy demand of the facility with additional renewable assets that are powering the facility at all times within the same region, same grid connections.
Got it. I imagine a potentially bad way to do it would be to go build a facility and take renewable energy from other places that could be using it. So yeah, your goal, as I understand it, is to make sure there's additional renewable energy to power your facility.
Absolutely. And you can think we're at the pilot scale. So as you scale these facilities and there's increasing energy demand, we have to move towards things like energy storage, intermittent operation to align with when renewables are available, and probably purpose-built renewables. So building solar, wind infrastructure to power, specifically to power direct air capture facilities and truly integrate those two aspects of the technology system. So there's a lot of things that we'll look towards at scale that maybe aren't viable at a commercial pilot scale.
Yeah, that's amazing because then actually direct air capture becomes sort of an accelerator to renewable energy development.
Absolutely. And thinking of with creative deployment, it can be load following too. So you can use inexpensive renewables when they're available. And maybe more on that to come.
Yeah. And tell me about the concrete. So what's the significance of that?
Yeah. So there's a company called CarbonCure that stores CO2 in concrete. And we actually signed an agreement with them through 2025 to permanently store atmospheric CO2 captured by Heirloom's direct air capture process in concrete. And they actually mineralize the CO2 in concrete. So it stores the CO2 for centuries. And Heirloom was the first company in the world to store atmospheric CO2 in concrete in February of last year. And that was with our partners at CarbonCure.
And why is that? Because I think the process we talked about last time we chatted was you inject it underground. Why should we care about doing it in concrete versus putting it underground? What's the benefit there?
Yeah, so right now we're working on building out what's called Class 6 infrastructure, which is actually the infrastructure required to inject CO2 underground and permanently store it in these geologic reservoirs. In the interim, concrete poses a way to store up to tens of millions of tons of CO2 permanently away from the atmosphere while also utilizing it for a product. So you get a CO2 storage benefit. You also get a added strength benefit for the concrete that you're producing, and it allows you to use less concrete. So you get a reduction in emissions from the concrete production process as well, which is really a triple whammy for benefits around storing CO2 in concrete.
Is there any reason to continue pursuing underground storage? Is there a capacity limit with concrete, or how do you look at that?
Yeah, concrete can only store so much CO2. So when you think of the 5 to 10 billion tons of CO2 that the Intergovernmental Panel on Climate Change estimates that we'll need to remove from the atmosphere, we need much, much, much larger storage infrastructure to handle that amount of CO2. Well, CO2 in concrete has a lot of added benefits, and we should definitely keep doing that. We'll need dedicated storage reservoirs to get us to the scale that the climate crisis needs.
Tell me about these offtake agreements and what they mean for you and the company.
Yeah, we're super excited to be working with customers like Microsoft and Stripe and Meta. And actually, one of the more recent offtake agreements we had was with Microsoft to deliver 315,000 tons of carbon removal over multiple years. This agreement is not only one of the largest in carbon removal, but one of the first bankable CDR contracts in history. And I'm happy to talk a little bit more about that. But what this does is it really allows Heirloom to unlock catalytic project finance. And that allows us to build out future direct air capture facilities, which is very similar to kind of power purchase agreements that propelled the development of wind and solar projects. It's been very instrumental in allowing for the continued deployment of the technology. And we're super excited to continue working with Microsoft as well as other off-takers to build out the technology.
My understanding is with these kind of first-of-a-kind technologies, it's unlike solar in that there's a bank looks at a project development like that and sees a lot of risk that the investment isn't as solid as it might be with solar development or a wind farm or something like that. So what is it that makes this agreement with Microsoft bankable that others are not?
The deal in its essence provides predictable and durable cash flows that are really needed for project financing. So project financing is looking to essentially finance a project with a foreseeable return on that investment of upfront cash for the project's development. And most, if not all, planned direct air capture facilities really rely on venture capital money to expand, which is expensive. And project financing, on the other hand, generally requires kind of single-digit returns. And the ability to project finance a big development like this is really advantageous for a lot of reasons, especially given that kind of single-digit return on investment. It also is a proven mechanism for building out large-scale infrastructure. A lot of mega projects are project financed, and we actually saw it be very catalytic to the wind and solar industries in early days, especially when those technologies were more risky and more first of a kind than they are today.
So was that instrumental in getting this first development off the ground in the facility you mentioned, the one in California?
No, that was very similar to other planned direct air capture facilities. That one relied more on venture capital.
Okay. But for future facilities, you're able to say, look, we've got this. You go to a bank, we have this purchase agreement. It's solid, like sort of guaranteed cash flow as long as you can deliver the carbon removals. And banks are saying, this is a good investment for us. We'll finance your next facility development.
Yeah, it's still a challenging process, but we have the pilot scale commercial facility in Tracy, and we've got the offtake agreements, and we're on our way to getting to project finance.
Is that first facility important in making you more bankable?
The first facility is important in de-risking technology. I mean, we've executed on a larger scale project that involves mobilization of construction. It involves building larger scale infrastructure. It involves multiple party management and working with general contractors. And that level of execution helps show that we can execute a project, as well as demonstrates the viability of the technology now that that facility is operating and taking CO2 out of the atmosphere.
On the kind of partnerships front, I saw that there was an announcement about a partnership with Lilac, and I didn't look deeply into it, but I understand they make an electric kiln. Can you say more about that and what that means for Heirloom?
So one of the things that you mentioned earlier about our technology is that we require a higher temperature reactor to pull the CO2 off of our mineral. So we entered into a partnership with Lilac to integrate their reactor technology within the direct air capture process, as well as continue to develop that reactor technology. So Lilac has an all-electric powered kiln that allows you to capture a pure stream of CO2 from the reaction happening inside of that kiln. And that is important for us because it's easily electrified as well as easy to capture CO2 from. So where Lilac plays a role is our limestone's fed into that renewably powered Lilac kiln. The CO2 comes off and is separated, and we can permanently store that either in materials like concrete or underground. This is important for a lot of different reasons, but one, this Lilac technology was really developed with the cement industry and the lime industry in mind. So they have vested interest in driving down the cost and making this as energy efficient as possible for those commodity operations. And then the Lilac reactor has been developed in coordination with folks like Heidelberg and Cemex and other big players who are very keen on making this cost effective and has a direct application to direct air capture. So we can continue to develop the direct air capture technology, going to larger and larger scales, while also having the benefit of optimizing in conjunction with kind of the cement and lime industries. It's exciting.
Yeah, super exciting. One of the things you helped me understand is how this voluntary carbon removal purchase market was growing and how that was such an important kind of fuel to the industry. And the way you characterize it at the time is that the market demand was still much higher than the supply of quality removals. But at some point, we will need to start having mandatory carbon markets and mandatory compliance starting to increase the level of purchases as supply meets that demand. I'm curious, like, where in that evolution we are today, if things are trending in a different direction than they were a couple of years ago, what that looks like.
Yeah, we're still trending in a similar direction. So demand is growing for this kind of permitted and responsible carbon removal. And today, most of the customers are still voluntary corporations with net zero targets, Microsoft, Stripe, Meta. And research from the Boston Consulting Group actually shows that there's strong and growing demand from these types of buyers for carbon removal through those voluntary markets, and that there will be a shortfall in supply by 2030. So that said, there's this demand from the voluntary markets, and we still very much believe that compliance and procurement markets are absolutely critical to achieve net zero at the pace that's required to combat climate change. So very much in a similar boat. There's definitely more buyers coming into the space, increasing demand, but it still needs to be supplemented by these compliance and procurement markets.
You had said you have a target of 1 billion tons by 2035.
We do.
So now we're a couple of years closer to that. How do you feel about progress towards that?
We're at a 1,000 tons of CO2, up to 1,000 tons of CO2 capture per year. We're making progress, and I'm optimistic that we will get to 1 billion tons. And I'm excited to see how fast the technology is growing. In a matter of years, we've gone from this petri dish scale to opening North America's first commercial DAC facility. And I'm persistently optimistic. It's one of our values and something that I really try to embody.
Yeah. How have things changed for you personally? I know you're a founder. You started very much on the kind of science, fundamental science side of, and the research that you talk about, the petri dish stage. What has it been like for you personally to see the company evolve like this? And what does it mean in terms of how your role is changing and your responsibilities are changing?
Yeah, it's an excellent question. And I reflect on this a lot. I always start by saying I'm so immensely proud of the team that we've built. Truly incredible scientists, engineers, commercialization folks that are driving this technology's growth. It is amazing to see. It is encouraging to see. And for me, I've learned a lot about scaling technologies. My image of myself 2 years ago, twiddling away in the lab, has changed significantly. I now know more about what it takes to operate some of these facilities, to actually go through a construction process. And the amount of information and learning that I've been able to have from that is amazing. And I'm deeply appreciative and grateful for it.
Has anything been a lot harder than you expected?
This is a naive answer, but construction has been harder than expected, probably because I just didn't have as much visibility into what it takes to build physical infrastructure. And it's something where we've brought on folks who do have that experience on the Heirloom team, and they've been able to educate us and push us in the right direction for the long term, because construction is going to be such an instrumental part of scaling these technologies.
And that's a good reminder to me. I should give a shout out. There are some amazing photos of what you have constructed, this facility in Tracy, that we'll put in the show notes, but people should go check it out. It is a beautiful thing. And unlike anything I've seen before, North America's first commercial direct air capture facility looks like. It's really cool.
Every time I go out to the facility, I'm in awe of what we've been able to accomplish.
I was going to ask you how optimistic or pessimistic you are, and if that's changed a lot, because last time we talked about you were pretty optimistic. I think you've answered that pretty well. Sounds like you're pretty optimistic.
Yeah, I'd love to flip that back at you again. And after 50 episodes, how are you feeling?
I've been considering not even asking people that question because everybody's optimistic. Yeah. And that is contagious. And I think, I also feel optimistic. But I do think I have a different understanding of just how diverse the number of innovations and that we need to solve the number of challenges we have. There are no silver bullets. We have to invest in one thing and not other things. It's sort of this everything, everywhere, all at once kind of thing.
To work in this space, you have to have a level of persistent optimism. You're chipping away at what is a massive problem that's going to take decades to solve, and it's going to require innovative solutions across the board. And in order to continue working on that problem, there does need to be a level of persistent and unrelenting optimism around the work that you're doing.
It's really impressive to see what you've done since we chatted last. What are you most excited about? What can people who want to follow Heirloom's progress, what can we look out for in the coming months and years?
Yeah. Super excited about direct air capture hubs and being a partner for partnering with the DOE. That is an exciting milestone. And then keep an eye out for how we scale. We've been moving really quickly, and now we're excited to keep building. And more exciting announcements to follow. We're continuing to grow. So for folks that are interested in direct air capture or getting involved in climate, check out our jobs page. We've got a lot of interesting roles, and we need a lot of people to be working on climate to have a positive difference.
That's so awesome, and a good call to action.
Yeah.
Noah, thanks a lot. Really good to catch up.
Thanks for having me. It's always a joy.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.